So in this question, it is said that a 6-coordinate transition metal complex is ESR and Mossbauer active. Okay. The effective magnetic moment is given for this complex, which is equal to 5.9 Bohr magnetons. So the first part of the question asks that the metal ion along with its oxidation state and the number of unpaired electron present are. So we have to consider this given magnetic moment, and then we have to identify which metal ion this is and how many number of unpaired electrons are present for this metal ion. So first of all, let's use the given magnetic moment to calculate the number of unpaired electrons in this particular complex. So we apply the spin only formula, which says that mu s is equal to under root n into n plus 2, where n is the number of unpaired electrons. And it is given as 5.9 Bohr magnetons. So looking at this value, we have the nearest number, which is square root of 35, which gives us 5.9. Okay. And from here, we can identify how many unpaired electrons are there. So we will have number of unpaired electrons is equal to 5. That means this particular complex has the metal ion which has n equal to 5, number of unpaired electrons equal to 5. Now, how many options we have for n equal to 5? So option A says Fe in the second oxidation state and 4. Option B says manganese 2 and 5. Option C says Fe3 and 1. And option D says Fe3 and 5. Okay, so we have two options where there is Mn and Fe, which has 5 number of unpaired electrons. Okay, here and here. Okay, so if it is Fe3 plus, then do we have 5 number of unpaired electrons? So Fe has a valence electronic configuration of 3d6 4s2. Okay, right? So Fe in the plus 3 oxidation state, how many electrons it should have? Plus 3 oxidation state, yes, it should have d5, 3d5, 4s0. And what about manganese? So neutral manganese has 3d5 4s2 electronic configuration. And what about manganese 2? So manganese 2 has 3d5 4s0. So both Fe3 and manganese 2 have 3d5 4s0 valence electronic configuration. So we have a possibility of these two complexes, both the manganese and the iron, in the manganese in the plus 2 state and iron in the plus 3 state. So both. So there is possibility of B and D answer to be correct. Okay. While it is it has been studied that iron in the plus 3 state can be both ESR and Mossbauer active, while manganese is heavily active in the ESR. If it is asked that which one can be studied by both techniques, so most probably it will be Fe. Even if we write manganese, then also it's a bit tricky question. So manganese can also be the correct answer. Iron can also be the correct answer with the 5 unpaired electrons. Now there is a second part to this question again. So the second part of the question says, asks to identify the complex. So which one among these should be the complex? Okay, so we have MnH2O whole 6 2 plus. So here Mn is in the plus 2 state with 5 unpaired electrons. This could be a possibility. Then there is Fe, H2O whole 6 2 plus. So Fe is also in the plus 2 state, which is not a possibility. Then we have FeCN6 3 minus, where Fe is in the plus 3 state. This could be a possibility. And here FeH2O whole 6 3 plus. Fe is in the plus 3 state here also. So out of these, which one should be the complex? Okay, so in the first case, there is a probability that manganese 2 can be the complex. Fe2 cannot be. Fe3. So Fe3 also has a probability. Both of these can be the complexes because Fe3 in the plus 3 state, it has 5 unpaired electrons. But option C has a strong field ligand which will have a tendency to pair up the Fe electrons. The probability of 5 unpaired electrons in this complex will be less. So this option is also neglected. So any of these two can be the complexes. Either this FeH2O whole 6 3 plus or MnH2O whole 6 2 plus. Okay, so out of these, any A or D could be the correct answer, but in all probability, according to the whatever data we have, scientific data, so Fe should be the correct answer because it is studied through both methods. It is ESR active as well as Mossbauer active, although Mn in the plus 2 state is also active for ESR and Mossbauer, but it is exclusively studied only through ESR methods because of its very clearly visible 5 unpaired electrons. Okay, I hope this explanation is clear. It is a tricky question and we have to deal it in a certain way. So hope it is helpful and thank you so much.